Hello everybody and welcome. Today we're going to be starting a new chapter and we're going to be talking about circular motion and gravity. Okay, so let's start with the first lesson and introduce what is circular motion. Okay, so imagine you are tying an object to a string and you start rotating this object at a constant speed. So we must be rotating this object at a constant speed. Now, if I'm rotating any object at a constant speed, we will have something called a uniform circular motion. Okay, but what if I'm moving this object at a varying speed? In other words, it's speeding up, then slowing down, then speeding up, then slowing down. Well, actually, in this case, it is a circular motion, but it's not a uniform circular motion. Today, or this chapter, we're going to be talking about uniform circular motion. So any other forms of motion is not considered. So we will only be talking about rotating objects at a constant speed. Okay? Now, to make things clear, we must introduce some terminologies related to uniform circular motion. And let's start with this image right here. It shows an object that is being rotated, as you can see. This is the center of rotation right here, and the object now is rotating at a circular motion. Okay, so this is our object. Now it's clear that the object is rotating counterclockwise. Okay, now is the direction important? Actually, not very much. We will see why right now. Now, let's first of all introduce something called the period or the time period. The time period, it is the time needed for the object to go one full rotation. So if it took this object, for example, 2 seconds to start from this point and rotate a full rotation and go back to its original point, let's say it took it 2 seconds, this means that the time period is 2 seconds. So it's very simple and clear. It's just the time needed for an object to go one full rotation. Now frequency, it's very much related to period. Actually, they're just inverted from each other. So if you want to introduce frequency, we can say that it is how many cycles does the object go in 1 second. So let's go back to our first example. We said that, for example, if this object takes 2 seconds to take one full rotation, this means that the period is 2. But if I change the question, if I ask you, what is the frequency of this object? In other words, how much does it go in 1 second? Okay. Now, we know that it takes a full rotation in 2 seconds for a full rotation. So in 1 second, it will only take a half rotation. So we can say that the frequency in this case is half. And they are related mathematically, we will see now, right now. So the idea is frequency is how many cycles or maybe parts of a cycle does the object go in 1 second? How much does it move in 1 second? Okay, so there's a huge difference between period and frequency, but they are very much related. Now, next terminology is tangential speed. What is meant by tangential speed? Well, actually, it's the object's speed along this imaginary line. See this imaginary dashed line right here? The object is going around this path, and what I'm asking here, or what I'm saying here, it's what is the velocity of this object along this path? As you can see, the velocity or the direction of the tangential velocity, it keeps on changing. But we already said that this speed is constant. The speed or the tangential speed, it is constant. It does not change in magnitude, but it keeps on changing its direction, because we know that velocity, it's a vector quantity, right? So velocity is a vector quantity. We know it has a magnitude and we know it has a direction. Okay, now since the magnitude is not changing, we can say that it is constant, so it's not changing. Okay, it does not change, but the direction, it's variable, it keeps on changing. So we have a change in the velocity, but it's not in the magnitude of the velocity, it's in the direction of the velocity. Now, let's go back and ask ourselves an important question. Since the velocity has a constant magnitude, does it have acceleration? Well, all of you are going to say no, because the speed is constant. Since there's constant speed, this means that there's no acceleration. Well, yes, the magnitude of the speed or the velocity, the magnitude of the velocity is constant. It's not changing, but the direction keeps on changing. And since velocity is made of two important factors, which are magnitude and direction, one of them is constant and one of them is variable, this means that the velocity is changing. So we have changing velocity, but we have constant magnitude but changing direction. So this means that we have changing velocity. And if we have changing velocity, this means that we have acceleration. So we can say that centripetal acceleration, although the object is moving at a constant speed, which is in magnitude, the velocity is not changing in magnitude, it still has an acceleration towards the center of the circle due to the change in direction. So changing in direction here is what's causing the acceleration. And what's important, says that the acceleration is always towards the center of the circle. So if I ask you where's the acceleration at this moment right here, you're going to say that the acceleration is here, and we will give it AC because it's for circular motion, so we can differentiate it between it and other forms of acceleration. So at this point it's here, AC. At this point it's here, AC. So actually the acceleration is also changing, but not in magnitude, it's also changing in. So we now understand the main terminologies. So let's talk about the first terminology, which we already introduced, which is time period. Time period is actually straightforward. So if I want to know what the time period for an object that is rotating, I can simply say that it is the time taken, or the time measured, divided by the number of cycles that the object finished. So for example, if an object went 5 cycles in 10 seconds, I can simply say that the time period is 2 seconds for each cycle. Okay, so the time period is measured in seconds. It's equal to the time measured to repeat a certain number of cycles divided by the number of cycles. Now the centripetal acceleration, which we already introduced, it's simply equal to Vt squared over R. Now AC, it's the centripetal acceleration. It's also measured in meters per second squared, and R, it's the radius of the circle. Again, it's the radius of the circle, and it's measured in meters, not in centimeters, etc. So if we have other types of units, we need to transform it into meters. Actually, it's important, so we will get the answer of the acceleration. It's in meters per second squared. Okay, and finally Vt, it's the tangential speed, which is measured in meters per second. So it's Vt squared over R. Okay, now if we want to find the frequency is 1 over time period. Actually, we introduced that in previous chapters. This is just as a reminder. So the frequency has a unit. It's called hertz, or second inverse. Now finally, if we want to find the tangential velocity, it's equal to 2 pi r over t. 2 pi, it's a constant number. R, it's the radius of the circle. And finally, t is the time period. So all these equations are very easy to use. So let's solve some quick problems. A car rounds a horizontal curve of constant radius at a constant speed. Which diagram best represents the direction of both the car's velocity and acceleration? So, in other words, it's saying here that a car rounds a horizontal curve, so it's a circular motion, at a constant radius with a constant speed. In other words, it's saying that the object is going through a uniform circular motion. And as we mentioned before, we are going to cover only uniform circular motion. Now, which diagram best represents the direction of both the velocity and the acceleration? Well, we said that before, we introduced it before that. The velocity is always tangential to the direction of movement, so it's not A, it's not B. It can be either C or D because the velocity is tangential. Now, the acceleration is always towards the center of the curve, so the answer is C. And we already mentioned that the acceleration is always towards the center of the curve. Now for question number 2. Which statement about the velocity and acceleration of an object traveling in a circle at a constant speed is true? Again, it's asking me about uniform circular motion. Neither the velocity nor the acceleration is constant. Both are constant. The acceleration is constant, but the velocity is not. And the velocity is constant, but the acceleration is not. Well, actually, the true answer is A. Some of you are going to say why? Because we mentioned before that the acceleration has an equation and the velocity has an equation, and they must be constant. Well, actually, yes, they are constant in magnitude, but they are always changing their direction. Because they're always changing their direction, this means that they are variable. So the tangential velocity and the centripetal acceleration are both variable because they keep on changing direction. Okay, so that's why the answer is A. Okay, so we're going to write this down. They keep on changing their direction, so the answer is A. Next question says that a car travels around a circular track of radius 20 meters. So, okay, we have the first piece of information says here that we have the radius, okay, at a constant speed of 10 meters per second. So it's moving at a circular motion. So this speed, it's the tangential speed. So it's Vt. Now, the magnitude of the car's acceleration is, well, actually, it's straightforward. We can say that the centripetal acceleration, we're going to use a small c here to differentiate between it and normal acceleration. It's equal to Vt squared over R. So we can say it is equal to 10 squared over 20, which is 100 over 20, which is equal to 5 meters per second squared. So the answer is simply B. Easy and straightforward. Okay, stay tuned. In the next videos we will be introducing more topics related to circular motion. See you then.